Hey there, my name is Thilo from Murzilli Consulting. We're here today at Aerial Cities 2025, our invite-only and exclusive Drone Talks event, this year in Dublin, Ireland. And I'm here with me having Alastair MacLeod from Ground Control. So pleasure to have you. Looking forward to get to know you and Ground Control a little bit better in the next few minutes. And yeah, if you would kindly introduce yourself and what Ground Control is doing as a company, that would be amazing.
Sure, thanks. So Ground Control, we're satellite IoT and tracking business, established more than 20 years, quite recently acquired by a French business actually called CLS. So we provide satellite connectivity and a lot of the engineering work to make the satellite connectivity work in marginal environments like UAVs. Therefore, obviously, our involvement with this event is helping people get some sort of satellite connectivity onto a drone, whether it's for calamatic purposes, BVLOS purposes, or other things.
Okay, perfect. Thank you so much. So if I understand it right, you are a vendor of the entire value chain solution to get a plug-and-play solution for satellite communication into a drone system or another application, so that you have a hardware device to plug into your vehicle and get an easy access to satellite communication for your UAV.
Right, exactly. So, I mean, the end-to-end chain involves a piece of hardware. Usually, it involves a network of some kind, and then particularly in a particular engineering environment like a drone, usually we also get involved quite early on with the manufacturer or the designer because there are factors that are particular to that environment: payload, small amounts of physical space, relative lack of electrical power. So we work, at one extreme, we sell you a box and we'll connect it to a satellite for you. At the other extreme, we'll work with you from the beginning on how can you optimize everything around the comm so that your finished product is also optimized.
Okay, perfect. Very helpful for the vendor to not do the individual or the OEM in the end, not doing the individual steps, but getting more a box or out of the box solution to have satellite communication in their devices available. Why is satellite communication required for command and controlling or other connectivity solutions that you want to have on a flying platform? What is a benefit, a must-have for satellite communication compared to other communication means over LTE broadcasting and so on?
I mean, the obvious benefit, which is realistically the main reason why satellite gets used, is when there is no cellular, or when cellular can't be relied upon, or when there's an imperative to have a second form of communication to back up the cellular. And I would say we are most involved where satellite is used as the primary. In other words, for whatever reason, the application chooses to use satellite for all its communications rather than only when other things fail. So that's, I suppose, that's the underlying reason why we exist in this market. And in the cases where we get involved, why is satellite used on drones variously, some of which we support, some we don't. If you call it like the most basic end, as in smallest amount of data, but still critical, telematics and telemetry, like condition monitoring, what's going on, small packets going back and forth to say I'm alive. It can be used for critical things in BVLOS situations, like when you lose the primary bearer, you can send it a very reliable message to say return to base. So we have at that end, that's probably the sort of the smallest, lowest bandwidth, and frankly the cheapest end of the market. In the middle there, we're quite active, working with people on BVLOS. So in satellite terms, we might call that mid-band connectivity. So you have to have an open communications path that's active all the time, so you can be simultaneously sending instructions and receiving them. And then at the sort of the higher bandwidth end, where people want to send like large amounts of data as a payload back, that we tend to do less of that. So you will hear people starting to talk about using networks like Kuiper and Starlink. And if you want to put a camera on your drone and you want to send back streaming live 4K video, then you need a lot of data for that. That's much more of a plug and play situation. Like, you don't really need smart engineers to help you optimize that. You just buy a terminal and plug it in, but it also comes with its own drawbacks, and it's not so suitable for BVLOS, not so suitable for smaller form factor drones, and absolutely not suitable for like emergency telemetry or emergency return to home type stuff.
And I think especially in the drone industry, payload weights is always a challenge. Form factors are challenges. So definitely not everybody has the capabilities to bring big technical devices on board to your vehicle.
Exactly, it can be. I mean, there are so many factors. I mean, we work with a particular company in the States who were designing a small to mid-sized drone, and we're looking to use mid-band connectivity. Their project has now been pivoted to a really large drone that looks like an airplane to me. They no longer seem to have any constraints around bandwidth around a payload size or weight or power, and they are going to use Starlink for that project. We have several other projects we're working on right now where realistically anything that draws more than 700 milliamps simply won't work. So you need something that's small and light and doesn't use much power, otherwise it doesn't fit the use case. So the more you get towards optimizing the engineering and the design and fitting a system that's built for purpose, the closer you're getting to what we do, the more you can, buy it from RadioShack, the less it's what we do.
Okay, perfect. And with what you're explaining on the services and the specific requirements to the devices and the communication infrastructure and the communication device, then of course you have the right product or an adaptable product to fit the need of the customer. So it's not a one product fits everything, but tailored to the specific needs. And if you could potentially elaborate a little bit on the different products that you're having, or what are the differences between the hardware and software solutions that you're offering?
Definitely. So at the smallest, lightest, cheapest end, frankly, we would provide an integrated small component, looks like a small circuit board. It would fit very easily into any system that somebody's designing, and it would provide you with the minimal amount of connectivity to send things like a how are you working message, or is battery still fine message, or please come home message, right? So it's a small piece of hardware where you're basically buying a circuit board. We've taken away the complexity of making it work nicely for you, so you don't have to learn about satellite, but everything else you're just buying a board. As you sort of work your way through, we would take that board. There are then more sophisticated versions that can send more data. We then move into kind of encapsulated versions where what you're buying is the thing that kind of looks like a finished product. It's got a nice case and it's got recognizable external interfaces. And most of what we do, we tend to offer it either in an encased version or a circuit board version. And for some customers, we go as far as saying, okay, well, what we need to do is for your specific case, we need to re-engineer what we've built to make it fit your use case. That could be something really basic, like changing how it mounts, or it could be something much less basic, like changing how the firmware operates to make it mirror what's on the drone. But the advantage of being our size, I would call us sort of mid-size in this market, is we have enough scale to build proper products and to maintain our quality and so on. But we're small enough and nimble enough that if you want to change something, we can re-engineer things to meet a particular use case. Not usually on a volume of one, but as soon as somebody's building a decent proportion of a decent number of drones, we can make something that'll work for your particular case.
Okay, interesting. And by this, with the evaluation or evolution of the products that you are offering to the market, and I think as you just mentioned in the beginning, there's also movement in the company overall, being a combination now of multiple companies going into ground control as the mother company. Is there a change in the market? Is there, in the specific field of satellite communication, something evolving, different requirements? Do you see the industry change, and by this the requirements to you as a company and products that you're offering?
There's a lot happening in the market right now, actually. So traditional services that have been around a long time, I'll give as one example, I'll give the network Viasat, which is known to more people as Inmarsat. These guys have they're geostationary satellites, so they're a long way away, but their one satellite covers a big area. We've been selling that product for more than 20 years, I think. But more recently, that network is evolving. The ground or the base station technology that uses it is evolving, and they now manufacturers are now building terminals that would work on a drone, whereas previously they absolutely wouldn't have worked on a drone. You had to point an antenna at the sky, and you had to be pointing it exactly the right place. So that brings that technology in, and that opens up things like relatively low bandwidth video becomes a possibility at an affordable price. So that's new. The bit that everybody knows about is at the high end of the market, high end bandwidth terms. You've got Starlink already, Kuiper coming, essentially broadband on a terminal for satellites. And provided you've got the power and the space for it, that can be a fantastic solution. I think some consideration needs to be given to which network you use for which purpose, but there's lots of value to be had from that. And then the big development, that sort of spans the industry. A lot of drones that you know today will be using cellular for connectivity, especially in metropolitan areas, right? But there is a general convergence between cellular connectivity using a terrestrial cellular network and the same cellular technology being applied to satellite network, so that in theory, you gain the opportunity to move out from the terrestrial coverage and carry on. And actually, it is a topic that's, at the moment, we think massively overhyped and overtalked, and it won't work the way people think it will work for at least 5 years. But there's no doubt that there's a direction of travel there. And because everyone's asking, again, one of the things we can bring to the table is to help people navigate that. Like you don't want to ignore the technology and then find 3 years later you should have paid attention. You also don't want to engineer around something that won't work for 5 years. And you need experts to help you navigate that.
Okay, so like an evolving market, evolving technologies, and bridging future, very scientific, realistic, but still a little bit out in the future solutions by today's engineering knowledge capabilities to enable operators to continue their operations, improve and work towards scaling operations, but in a reasonable and realistic manner together with your solutions.
Exactly. The other thing, which actually you haven't asked me about, but it's quite central to a lot of what people in the industry will care about, is that the economics have been moving in a favorable direction as well. So I have only been in the satellite comms industry for 5 years. I'm a relative new guy. And if you went back 5 years, certainly if you went back 10 years, the mindset of everybody involved would be to assume that it was prohibitively expensive for more or less everything. Now it's not quite mainstream, and still you pay a premium, but you should, because space is a long way away and it's quite expensive to put a cell tower in space. But nonetheless, like we're now, if you look at the overall cost of what you pay per data, we're probably somewhere around 20 or 30% of where we were 10 years ago for data, and in some cases less. So it starts to become, at the same time as other technologies and all these regulatory frameworks are all starting to emerge, and the potential for UAVs to operate becomes a reality, at the same time that the satellite technology and the economics around it are all also moving in the same direction. And I think that's a big driver for why people are now taking satellite on UAVs much more seriously than they were 5 years ago.
Yeah, absolutely. And I think that is a huge topic. Like commercial viability and costs are a key driver or enabler for scaling operations. So I think that is very interesting to hear. Thank you so much for the insights. Are there any final takeaways, considerations to share with the community, with the industry from a satellite network provider and solution provider that you want to share with the industry?
Look, I think the industry's becoming very well informed in its own right anyway. So just to give my perspective on how we would look at it, if I look across the different projects you've already been involved with, there are undoubtedly people building airborne systems where one bearer is enough, either the space or the money doesn't allow for more than one. Some of these projects, the drone won't be used twice anyway. So I suppose, the different considerations for those sorts of things. In commercial operations, I think where satellite has a role is it can be the primary source of communication. It can be the backup source. It can be the sort of emergency failover thing. And although I wouldn't profess to be a drone industry expert, I'm sure that surety of communication is going to be vital for safety. It's going to be vital for the adoption of a lot of different use cases. And I think what we'll see in terms of satellite usage is, yes, satellite for primary some of the time, but also satellite to ensure you never lose connectivity, and satellite to ensure that there is always a way of kind of sending a sort of an emergency panic, come back immediately, message to your system. And it wouldn't surprise me at all, as these things operate more and more over urban environments, where cellular is the obvious sort of primary bearer to use, that these devices need to have 2 or even 3 different technologies on them to make sure that there are no circumstances where you can't communicate. And for that reason, I think we've got a lot to offer.
Perfect. Thank you so much for the insights, Alastair.
Right.
Thank you for sharing what ground control is doing and offering. Very interesting to continue following the market and the requirements about connectivity and satellite as a technical solution for that.
Okay.
Thank you for the time.